quadratic graphs, we're going to be covering topics in the standard 2.3b and 2.6d, and we're also going to be covering topics taught in the Study Island lesson, quadratic graphs. I hope that you can join us today, and don't forget sitting notes as you're going along. You should be taking notes as we are going through the lesson, and if I go too fast, just pause it and rewind so you can get caught back up. You can also pause at the beginning of a question, see what you think the answer is, and then watch how I work it out. And that way you can learn from any mistakes, and also get a good gauge of how well you are remembering how to do these problems. And so for today's lesson, we're going to be focusing on the different parts of a parabola. We're going to be looking at the vertex, the axis of symmetry, the x and y axis, the axis are. So if you've been encountering any of those questions, this is exactly what you want to be. So let's go ahead and get some questions.
The graph of a quadratic is called a parabola. And this here is an example of an up parabola. You can also have parabolas that are going down, like this. Okay. And when we're graphing these, or when we're answering questions about these, knowing different parts of them is helpful. So the different parts of a graph, you have the y-intercept where it crosses the y-axis. You have the x-intercepts where they cross the x-axis. And sometimes these are called solutions. Sometimes they're called zeros. It's all the same part of the graph. And then you also have what's called the axis of symmetry that runs through the vertex. So the axis of symmetry, if you were to fold the parabola in half, it would be the exact same on both sides. And the vertex is either the lowest or the highest point. When it's the lowest point, we call that a minimum. And when it's the highest point, we call that the maximum. And so as we look at the following questions, they're going to be asking us to identify these different parts of the graph. So we're going to go over how to actually find them. The first thing you could be asked to identify is does this parabola open up or does it open down? Remember, when it opens up, you're going to have a minimum point. That's the vertex. And when it opens down, you're going to have a maximum point at the vertex. And the way that you tell is you look at the coefficient, the number in front of your x squared term. Here, when that number in front of x squared is greater than 0, so it's positive, it opens up. It's a smile. Positive numbers bring smiles. When it's less than 0, so it's negative, it's going to open down. So when you have a negative number, you have a frown. Right, so in order to know if this opens up or down, we're just going to look at the coefficient in front of x squared. Here, remember there's an invisible 1 there, so it's -1. It's a negative number, so it opens down. So that means my answer is going to be A. This question also asks which direction does the parabola open. I'm looking in front of my x squared term. There's a +1 there. It's a positive number, so my answer is going to be A. It opens up. The next features we're going to look at how to calculate is the axis of symmetry and the vertex. So the axis of symmetry, we have this formula here. It's going to be x equals -b over 2a. The b number is the number in front of the x, and the a number is the coefficient in front of x squared. And so you just substitute those in and simplify to get your equation for the axis of symmetry. Now, we also use this formula to get the x-coordinates of the vertex. So once we have that x-coordinate number, then we have to substitute that back into the original equation to get the y-coordinate of the vertex. And we'll look at a couple of those examples for later on. Now, what's important is you can only use this formula when your equation is in standard form. So if this isn't in standard form yet, then you have to put it in standard form and then use the formula. So in this problem here, it wants us to find the axis of symmetry. So I'm going to do negative b or opposite b. So I have a positive 16 for my b number. The opposite of that is negative 16. All over 2 times the a number, which is 4 here, the number in front of x squared. So I just simplify that. Negative 16 divided by 8 is negative 2. So my equation here for the axis of symmetry is x equals negative 2, which makes my answer D. This question here is asking us to find the minimum or maximum of the function below. So it's asking us to find the vertex. So first I'm going to decide, is it a min or a max, and narrow down my answers. Well, the number in front of the x squared is negative, so that means it's going to be a frown, which means I'm going to have a maximum point. So that means any of these that say minimum, I can get rid of. So it can't be D. So it's going to be a maximum. So now I'm going to look at what is my minimum or maximum number. And what it's looking for is the y coordinate of the vertex. That's what this question is asking for when you're asking to find the min or the max. So my first step is to use that equation, negative b over 2a, to find my x coordinate. So here, I don't have an x term, so I don't have an x coordinate, so it's just going to be 0 on top. And then I'm going to have 2 times negative 8. And 0 over negative 16, if you have 0 of 16 things, you still have 0. So and my x is just 0 there. So then I'm going to, in order to find my y number, I'm going to change f of x to y. And then I'm going to substitute in my x number, which I just found to be 0, and solve that. Negative 8 times 0 is 0. 0 minus 7 is negative 7. So that means that my maximum number here is negative 7, and my answer is C. Another way to find the vertex that's fairly easy is when you're given a problem that the equation is in vertex form. So looking at some notes up here before we look at our question, the vertex form generically is our a coefficient, parenthesis x minus h, parenthesis squared plus k, where the point hk is the vertex. So to find the vertex, you take the opposite of the number in with x, and then you take the k number at the end by totally itself. And here's an example. So here it wants to know what value of x, so this time we're looking for x, not y, does the minimum or maximum occur for the function below. So here I'm just going to pull out my vertex number coordinate. So it's minus 4 in the parentheses, so that means 4 is going to be my x value. And I have negative 6 at the end, so that means negative 6 is going to be my y coordinate. It just wants the x coordinate here, so that's going to be either A or C. And I look, this is a negative in front of the x there, that for my A number, so that means it's going to be a frown. So that means I'm going to have a maximum point, and that makes my answer C, where I have the maximum and the x equals 4. Okay, in this equation, they want to know which one has a higher vertex, which one has the greater or lesser vertex. So the top equation here is, it's a positive out front, so that's a smile, and this one's a negative in front of the x squared, so that's a frown. So you could have something like this, where the minimum is higher than the maximum, or you could have something like this, where the maximum is higher than the minimum, or you could have something where they're actually touching right at the vertex and they're exactly the same. So we have to actually calculate each minimum and maximum to find out which one's going to be higher. So we're going to be using my formula, since these are in standard form, where x equals negative b over 2a, to find the x coordinate. So first we're going to do that for the f of x. my coefficient in front of the x term in f of x is negative 24, so the opposite of that is positive 24, all over 2 times the a number, which is the coefficient in front of x squared, which is 6 here. So that means I have 24 over 12, which reduces to 2, and that's my x coordinate there. So then, to find the y coordinate, I'm going to have to substitute 2 in to f of x. Anywhere that there's an x, I'm replacing that with the number 2. Okay, so here 2 squared is 4. And I do my exponents first, and then I'm going to do my multiplication. So 6 times 4 is 24, minus 24 times 2 is 48, plus 36. And when I go ahead and do all of that adding and subtracting, I get 12. So that means the coordinate of my vertex here, of my minimum, is 2, 12. And then I need to do the same thing with g of x. So I'm going to start with my x coordinate again. My b number here is a positive 2. So the opposite of that is negative 2 all over 2 times, and then my a number is that negative 1 that's in front of the x squared. And so 2 times negative 1 is negative 2, and negative 2 over negative 2 simplifies to 1. So my x coordinate is 1, and then I have to go ahead and substitute that in anywhere that there's an x in that g of x function to get my y coordinate. So 1 squared here is 1, so I have that negative out front, plus, and then 2 times 1 is 2, plus 2, and negative 1 plus 2 is equal to 3. So my coordinate here is 1, 3 for g of x. So remember, my f of x is a minimum, and my g of x is the maximum. So if I'm looking at which one is greater or smaller, I'm looking at, well, no, which one's higher or lower. So I'm looking at up or down the y number. So here, 12 is definitely bigger than 3, so that means my minimum is going to be bigger than my maximum, and that makes my answer here C. Now we're going to look at how to find the y and x intercepts of a parabola. And when it's in standard form, the y-intercept is the constant at the end. It's that simple. And then to find the x-intercepts, you have to solve for x. You have to set the equation equal to 0 and solve for x. And here's an example of how to solve for x when it's in factored form. And then those solutions that you get are your x-intercepts. So here it's asking us to find the x-intercepts. It's already set it equal to 0, so that means I just have to solve for x. You could use factoring, you could use quadratic formula, you could use completing the square, whatever, you could use graphing on a graphing calculator. Whatever it is that you're the most comfortable with, use that to solve for x. I see they're going to be whole numbers, so I'm just going to use factoring. So this is going to factor into x minus 12 and x plus 1 equals 0. And then to solve each of these, for 0, I'm going to go ahead, or for x, I'm going to set each one separately equal to 0 and solve. So here x is going to equal 12, and here x is going to equal negative 1, and those two numbers are my x-intercepts, 12 and negative 1, so my answer is A. Here it wants to know what is the y-intercept of the quadratic function below. It's in standard form, so that means that my constant at the end is going to be my y-intercept. So my y-intercept here is negative 12, which is letter A. Now we're going to take all of the knowledge that we've learned on how to identify the different pieces of a parabola in order to take one parabola and match it to a graph. So first thing is, these all start with a negative, so I can't rule any out for being a frown, an upside down parabola. Next I look, and my y-intercept is a positive 6, and these are all in standard form. So that means I need to have a plus 6 as my constant at the end. So C and D have a minus 6 and a negative 2 for their y-intercepts. So it can only be A or B. Next, I'm going to look, here's my vertex. I'm going to see if I'm going to find what the x-coordinate of that vertex is for both A and B and see if that gives me my final answer. So A, if I take negative B, opposite of B, my B number is -1, so the opposite of that is +1, over 2 times the A number, which is -1 in choice A. And so my x-coordinate there is going to be 1 over -2. So it's a -1/2. Well, that one makes sense. My x-coordinate could definitely be -1/2 there. So let's look at B to see if it gives me something different. So B, I'm going to have x equals, and then -b over 2a is the formula. So the opposite of my b number here would be -5 all over 2, and then the x-coordinate is also -1 there. And that's going to simplify down into 5 over 2, because my negatives cancel, which is +2.5, which would be over here. So that's definitely not the vertex coordinate, x-coordinate, so it can't be B. So my answer is going to be A. Thank you for joining us today, and I hope you learned something new.